Good morning students. In this video we can discuss what is meant by heap management, why we are using heap management. So it was also covers several sub-concepts like as what is the memory manager, the memory hierarchy of a computer, locality in programs, and reducing the fragmentation and manual deallocation requests. So in this video we can discuss first three concepts. Those are the memory manager, the memory hierarchy of a computer, and locality in programs. So now we discuss, first of all, now we discuss what is meant by heap management. So here actually heap management or heap is a portion of the store. So this store is used for storing the data. So that particular data is live independently or indefinitely. So otherwise that particular data is exit or deletes after execution of the program, or that particular data is available up to until the program explicitly deletes such information. So this is the process of heap storage or heap management. So that means by simply to store the data, for that purpose here heap management or heap memory is used to storing that particular data. Once we allocate such data in heap, so that particular data is available indefinitely. So otherwise that particular data is available until completion of the program, and that particular program or procedure can delete the whatever the data used by that particular procedure. So here whenever we are using the local variables, so typically such local variables becomes inaccessible whenever their parent procedure or their related procedure was terminated, their related procedure was execution is completed. After that whatever the procedures was created inside of the whatever the variables was created or whatever the objects was created inside of that particular procedure, such objects or such variables are not accessible to the remaining program or any other procedures. So at that situation, whenever we want to access such objects after completion or after execution of the particular procedure, for that purpose we can create our own objects in the program. So to create or to remove objects in that heap manager or heap storage, we use the memory manager. Here memory manager is responsible for allocating the space for some objects or deallocates the space for some objects. And here this memory manager is also responsible for providing the interface between operating system and system software. So that means to complete any or to create any object or to deallocate any object, for that purpose so it was responsible for providing the interfaces between operating system and application softwares. So now we discuss what is the major role of memory manager or why we are using memory manager and what are the major responsibilities of the memory manager. So here memory manager is responsible for keep tracking all the free space in the heap memory or all the free space in heap storage. So that information can be maintained in all times. So here this entire thing can be performed with the help of memory manager by simply performing the two basic functions. Those are allocation and deallocation. So here whenever a program requests some memory for a variable or some object, at that time memory manager is responsible for allocating or providing the whatever the memory is requested by the programmer or whatever the memory is requested by the program. So such memory is allocates to that particular program. So in this process, if that memory is available, then it can simply allocating to that particular program. In case that memory is not available, then it can search wherever that particular wherever the free amount of memory is available inside the heap. Once it finds that free space, then allocates to that particular program. In case it was not found by the memory manager, then which is responsible for getting some information or some memory, storage memory or some virtual memory from the operating system, and then allocate such virtual memory to the program. So this is the major process of allocation process of any variable or object space by using the memory manager. So here whenever we are going to deallocating any object or any variable related memory, so at that time the memory manager returns deallocated space to the pool of free spaces. That means So here all free spaces of memory spaces or memory blocks will be maintained as a sum pool. So when any object or any variable is returns or completes the execution, then whatever the memory occupied by that particular variable or that particular object, such information or such memory storage is list out as a free memory. So and then it can be allocated to the buffer pool. So this buffer pool maintains whatever the total list of free memory spaces or free memory blocks is available. So within that, so it can provide whatever the recently deallocation of memory space. So such space can be provided to the buffer pool. So these are the responsibility of the memory manager by simply allocation of the space for any variable or object and then deallocation of the space for any variable or object. So in this process, so to providing the better allocation or deallocation process by the memory manager, so we are expecting or we are expected three major properties from the memory manager. Those are space efficiency, program efficiency and low overhead. So here space efficiency means memory manager should minimize the total heap space needed by a program. So that means here memory manager is responsible for try to minimizing the whatever the total space is required by the that particular program. So to minimizing that particular program, here memory manager can do larger programs to run in a fixed virtual address space. That means in case any large program is currently executing or currently compiling at that time, here memory manager is responsible for allocating some fixed space or some fixed memory to the that particular program. So that means in case that particular program can require 10 MB of data or 10 MB of space, but here memory manager can allocate either 1 MB of memory space to the that particular program. So in that process, that particular program is first execute some portion of the that particular program. After completion of the execution of some portion of the program, it deallocates that particular memory space and complete the remaining portion of the that particular complete the execution of remaining portion of the that particular program. So in this process, so that means here memory manager is minimizing the fragmentation. So then it can effectively maintains the or efficiently maintains the space available in the system or in the computer. So that is the one property. Second one is program efficiency. So in this, memory manager should make good use of the memory subsystem to allow the programs to run faster. So that means here memory manager is responsible for program efficiency. That means to complete that particular program execution within short time or within less time. For that purpose, here memory manager is responsible for, based on the program requirement, it can allocate different sub type of memories. So that means in case based on the program necessity, it can allocate either register memory or either buffer memory or either some cache memory. In this manner, based on the sub functionalities, it can allocate the available memory and then completes the particular program execution fasterly. So this is nothing but program efficiency. And final thing is low overhead. So here memory allocations and deallocations are frequently performing in the operating system, or frequently performed operations in the any program. So that's why in this process here memory manager is responsible for how much time to access or how much time to deactivate or de-access that particular memory space. For that purpose, which can allows only low overhead or minimize the space between allocation and deallocation process of any memory space. So these are the three basic properties required by the memory managers. So now we discuss about memory hierarchy of a computer. So already we know when we are coming to the computer memory management system, so here actually available memory is divided into total process of execution or completion of any process. It requires different types of memories. So now we discuss whatever the different memory hierarchies of a computer. So here memory management and compiler optimization must be done with an awareness of how memory can behave. So that means while we are going to performing any compilation or any software implementation at that time, so here what is the process of memory or how the particular memory can be behaved. So such information can be must be known by the memory management and then compiler optimization. Then only these two can be efficiently utilize whatever the available memory to complete their executions. But in modern machines, without knowing such information, so without knowing such type of memory management and compiler optimization, programmers can easily write the programs, and after completion of their programs, here modern machines is responsible for how to utilize the particular programs, can allocate the memory and optimize the memory space. So such things can be utilized, such things can be already implemented by the machines. So that's why here there was no need to know about how to managing the memory space or heap space and how to optimizing the memory related variables or objects. So such things are not necessary for modern machines. So why? Because machines already know how to optimize and how to utilize available memory effectively. So here, however, the efficiency of a program is determined not just by the number of instructions executed. So that means here the efficiency of a program is not only depending upon the how many instructions can be executed within some period of time. So which is also depending upon the how much time or how long time it requires to execute each and every instruction. So it was also considered while we are going to optimizing the memory management. And the time taken to execute an instruction. So while we are going to executing any instruction, so for example there are two instructions, both instructions are same size, but there was no guarantee both instructions can be completed within same time. So in case instruction 1 may be completed within 1 minute, or instruction 2 may be completed within 10 seconds also. So that is based on the available memory. So those are varying from, that means so which type of memory can be allocated to processing the particular instructions. So that is based on from nanometers to nanoseconds to milliseconds. So now we observe what are the different memory hierarchies of a computer. So these are the different types of memory hierarchy of a computer. So those are register memory, first level cache memory, second level cache memory, physical memory and virtual memory. So here register memory is available inside the processor, whatever the based on the processor how much of amount of memory can be available. So here at least here register memory is available 32 words. So here each word is the capability of 2 bytes of memory. So that means here total is 64 bytes of memory is available in registers. So here this register memory can take 1 nanoseconds to complete the any execution or any data transmission. And next, first level caching. So this first level caching is available, their size is from 16 KB to 64 KB and their execution time can take 5 to 10 nanoseconds. And next one is second level of cache memory. So this second level cache memory can be available from 128 KB to 4 MB. And whenever we are using to execute or to processing any instruction by second level cache memory, then it can take from 40 to 60 nanoseconds to complete that particular instruction execution or instruction processing. And next one is a physical memory, that means either RAM, such type of memory. So here these are available from 256 MB to 2 GB of memory. So when we are using the physical memory as storing and retrieving the instructions, at that time it can take 100 to 150 nanoseconds. And next, whenever we are using any hard disk or any other virtual memory, those are available greater than 2 GB. So those are taking to complete one instruction execution 3 to 15 milliseconds. So this is these are the various typical access times based on the available memories in computer. So now we discuss what is meant by locality in programs. So in this session, maximum or most programs exhibit a high degree of locality. So that means they spend most of their time executing a relatively small fraction of the code and touching only a small fraction of the data. So that means whenever we are going to executing any large programs at that time, so out of those large program can use only 10% or only small part of the code can be used to complete the execution of that particular program. That means remaining part of the instructions or remaining part of the code can be used only rare cases or almost not used. So such for example, we say that a program has temporal locality. So here in locality in programs means we can declare or we can decide that particular program can be performed in which type of locality. So there are two types of localities are available. Those are temporal locality and spatial locality. See here, when we say that that particular program or that particular memory can be required temporal locality, and when we say that spatial locality means, for example, we say that that particular program has a temporal locality. So that means if the memory locations it access are likely to be accessed again within a short period of time. So that means that particular memory location is accessed by that particular program within short time. So same memory location can be located or accessed multiple times. So that type of memory accessing is known as the temporal locality. And when we say that memory or program has a spatial locality means if memory locations close to the location accessed are likely also to be accessed within a short period of time. So that means whenever that particular program or that particular memory can be accessed within a short period time, repeatedly accessing that particular memory location, then we can say is the temporary locality or temporal locality. So in case that particular memory can be accessed once, so until completion of that particular program, that particular memory location not be used again. So that type of memory locations is known as the spatial locality. So for example, whenever we are passing the arguments to the any procedure, those procedures can be used multiple times within some period amount of time based on our requirement. So in case we are using any variable declaration normal way, so that means once at the time of initialization we can use that particular variable until completion of the execution of that particular program, same variable or same variable value can be used within entire program. So these are the two types of localities in the programs. So temporal locality, spatial locality. So now we consider some example. So here actually in conventional programs or normal programs, so those are spending 90% of their time executing only 10% of the code only. So that means whenever we consider some program, so within that particular program, in case that particular program having either 100 lines or 200 lines, out of those 200 lines, so to complete the execution of that particular program, 90% of time, so that means maximum 90%, it can use only 20 lines to complete the execution of that particular program. In rare cases only remaining lines of code can be used. For example, instructions to handle illegal inputs and exceptional cases. So for that purpose, it was using some lines of code to handling the illegal inputs and some exceptional cases. So for that purpose, it was maintaining some functions or some header files. So those header files are those library or linked files are used rare times only. So whenever it was having some exception, then only it can utilize that particular part of the code. In case there was no exception, then it cannot use such part of the code in the program execution. Next, so how we are optimizing the memory hierarchy. So here to optimizing the memory hierarchy, we are using some policy. That policy keeping the most recently used instructions in some cache memory. So that means here the major policy is, so it will identify whatever the most recently used memory blocks or memory locations, and those memory locations or those memory related data can be located in cache memory. So based on this predictor, we can usually managing the memory usage. So that means whenever we are accessing some new instructions, so at that time, once that particular new instruction is executed, immediately after execution of that particular new instruction, next sequence or next instruction is also executed maximum. High probability is there to execute next instruction also. So that's why in rare cases we are executing some new instructions. So whenever we are frequently, so based on the history or based on the past, we can analyze whatever the instructions was frequently executed within that particular program. So such instructions can be copied into the cache memory to execute that particular or to optimizing the memory management or memory hierarchy of the particular program. So for that purpose, here there is some effective technique to improve the spatial locality of instructions is to have the compiler place basic blocks. So that means at the time of compilation, basically it can identify whatever the space is required to complete that particular program execution. Based on that, it follows the to providing the continuous memory locations or continuous memory to complete the program execution. Once that memory is allocated, then based on available memory, it can complete the execution. So here these instructions belongs to the same loop or same functions also have some high probability of executing together. So that means, so first of all we will try to check based on the past. So whatever the frequently used instructions, those instructions can be copied into some cache memory. And the second one is we can identify at the time of compilation how much memory is required to complete that particular program execution. Based on that, here memory management or optimization techniques is responsible for providing the continuous memory for allocating the space for the requirement memory of that particular program. After that, it can provide to accessing the memory for whatever the loops are used in that particular program and whatever the functions are used in that particular program. Those functions or loops can be also access some memory locations. So these are the several ways to optimizing the memory hierarchy. So by simply here we will, based on the past, we will identify what are the frequently used instructions. Those are preferred in cache memory. That is the first one. And next one, it can identify how much memory can be required to complete the execution of that particular program, and then try to provide that particular memory space. So that is the second one. And third one is it can try to allocate the space for continuously using any loops or any functions. Those those instructions can be directly accessing the memory. So for that type of instructions also can require some amount of memory. So we will here memory manager optimization techniques is responsible for providing such amount of memory to accessing that particular program. So these are the different approaches to optimizing the memory hierarchy. So these are the details about how to what is meant by heap management, and what is the role of the memory manager, and what is the memory hierarchy of a computer, and locality in programs. In memory manager is responsible for majorly allocation and deallocation of the space, and memory hierarchy of a computer is responsible for based on the program execution which type of memory is suitable for increasing the program efficiency. And locality in programs means nothing but here we discussed two types of localities. Those are temporal locality and spatial locality. So whatever the memory locations frequently used multiple times within short period of time, so such type of instructions or such type of programs is used temporal locality. In case whatever the instructions was used, once that particular variable or that particular object is declared or accessed, until execution of the program or until completion of their execution, it can access that particular memory location only one time. So such type of accessing is known as spatial locality. So these are the concepts we discussed in this video. In next video we can discuss about how to reducing the fragmentations and how to performing the manual deallocation request. Thank you.